Welcome, everyone. In the session, we have Gracie Ermi presenting Data Science for Wildlife. Just a quick note to please post your questions in the Q&A box instead of the chat. Gracie, off to you.
Thank you. And thanks everyone for being here. I'm really excited to get to present at WIDS today. I'm going to be telling you about data science for wildlife in general. I've been working in this space for about 4+ years now. And so I'll tell you about a few projects I've gotten to work on and then share just a bunch of resources with you if you're interested in this space and learning more and potentially also working in this very cool combination of computer science and data science and wildlife conservation. So, hello, I'm Gracie. Outside of tech and wildlife, I'm a knitter, I'm a sister, those are all my siblings in a lot of those pictures. I love to hike and get outside in the beautiful, Pacific Northwest area. And I'm also a science communicator. So I spend a lot of time talking about my work and my sort of STEM journey with audiences of all ages, because I think it's a really cool way, a lot of people care about the wildlife conservation side of things. And so I love getting to tell people, you can apply computer science in this space as well. And I think it's a great way to get a lot of people interested in computer science and data science who maybe wouldn't have thought they had that interest before. So what does a project look like that is applying data science to wildlife conservation? So a lot of the projects I've worked on have had to do with wildlife surveys. So that's a really important tool that wildlife scientists use to be able to study the species that they are interested in without harming the animal at all, or it's a very non-invasive method of collecting a lot of data about the animal and then being able to analyze that data and learn something from it. So they might use cameras to collect data. They might be collecting video footage of the animals. I've worked on a lot of projects where we're using aerial imagery, either taken from a plane like you can see in that picture or from a drone. I worked on a project using underwater video footage, which was really cool. And then a big challenge that generally exists in wildlife conservation, or has traditionally existed, is just being able to contend with all of this data that is collected in a wildlife survey. It's often manually processed. Either they might be, trying to estimate the population size of the animal, so they're going through these images or this video footage and counting the animals that they see. They might be trying to identify what species tend to spend time in which areas, so they're labeling different species that they see in the video or the images. Or they might be trying to collect different information about the individuals in the population, like trying to learn about their health, or identifying different individuals and seeing kind of individual behavior and how that might be changing. So it's a very manual process to go through all of these millions of images that they took, or thousands of hours of video footage that they took. And so that's where machine learning and data science can come in, or has come in a lot of the projects that I've been on, to be able to provide wildlife researchers with more automatic ways to go through this data that they've collected and get out the important stuff. And usually just automating like the most tedious parts of a wildlife researcher's job so that they can get on to the more exciting stuff, and use that data that they collect from these surveys to take action on behalf of the species that they study. So one of the really cool projects I've gotten to work on is this killer whale health metrics project. So this project is related to the southern resident killer whales, which is the population of killer whales that live right in our backyard in the Puget Sound. There are only about 75 of them left in the population. And so this project was all about collecting health metrics about the population and trying to understand, how different factors are affecting their health. And so I have a video to show you that will do a good job of explaining it succinctly, what we were trying to do.
You know when you're whale watching and you're like, "Hi, Stacy." Wait, or was that Charles? Well, don't worry, because scientists have developed a program so you'll never mix up your whale friends again. Did you know killer whales are actually large dolphins? Orcas, like other dolphins, grow up swimming alongside their families, and they stay in that pod for their entire life, making these groups easy to track and identify. For instance, 3 orca families make up what's known as the southern resident killer whale population. This group of endangered orcas faces habitat loss and a diminishing food supply. Helping these massive mammals is a Herculean effort. But these 2 scientists have a plan. Meet marine mammal researcher Holly Fernback and computer scientist Gracie Ermi. Holly's job is to follow the pod in a boat and help capture images using a drone. Back on land, Gracie codes a program to study Holly's whale pics, which hold clues to each whale's overall health.
So a lot of people think that flying a drone is the coolest part, but I really love my job that I get to watch what the whales are doing. Our research helps us identify whales that we call whales of concern. Then we could work with other groups, both at the state and the federal level, to ensure that they have the space they need to get all the food they need.
To first get their photos, Holly and her team head out to sea with a state-of-the-art drone, nicknamed Maximus. Once the whales are spotted, Maximus is hand-released into the air. And Holly ducks under her high-tech beach towel to cut down the glare so that she can direct the drone pilot to fly directly over the whales.
Keep going forward, 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 forward. Okay, you're picking up the whale. Looks like J16. Keep going forward. For each of these images, we may collect more than 60 measurements. We can measure to see how long they are, how wide they are. We're able to assess if they're growing like they should, if they're getting enough food.
This is where Gracie comes in. For her, conservation came second to her love of tech.
I decided to pursue computer science because I was told about all the different ways that you can use code and technology to make an impact in areas that you care about. Being able to combine my love of the environment with my technology skills was kind of a dream come true.
She's created a computer program to help Holly's team sort through their thousands of photographs to identify each whale.
First, we want to teach the computer to help us ID the whales. So we can use the saddle patch here on the back of the whale. And it's actually unique to each individual in the population. It's kind of like their fingerprint.
Once the computer matches the team's new photos with an image of a known whale, Gracie's program helps take body measurements too.
Based on different key points that it found, like the snout and the tail notch, the tool will be able to take an estimate at where some of the different measurements should be placed. And then you can go through and adjust as needed.
That would be a huge time saver. That's really exciting.
We know that it's never going to be 100% accurate all the time. And so we try to really build in a lot of ways that you can make sure what it's telling you is, the right thing and that you're saving really accurate data in the end.
Okay, that's great.
Holly and Gracie hope their technological efforts can aid wildlife managers in keeping these well-dressed whales around for generations.
It's really exciting to see how successful we've been at merging these 2 innovative tools, using drones to collect all the images, and then using machine learning and AI to analyze everything. It's just going to really help us aid in the recovery of endangered southern resident killer whales.
Hey.
Okay, so that gives you an idea of a project that I feel very lucky to have gotten to work on, and kind of how data science and wildlife conservation can come together. So another area that I have gotten to sort of explore recently is is the area of bioacoustic machine learning. So this is all about listening to the environment. We can learn a lot about an ecosystem, not just from taking images of it, but from recording sound, especially the impacts of human sound underwater is a big thing that a lot of people are looking into, because sound travels further and faster underwater than it does in air. And so anything that people are doing underwater, like shipping activity or like underwater construction, can have a really huge impact negative impact on wildlife. So these 3 pictures that you see here, these are of different hydrophones, which are just tools that are used to collect sound underwater. So they can be towed by a boat, they can be placed underwater, they can be like bigger sort of tools that are like always sort of anchored out there and collecting sound constantly. And we can use machine learning and data science again to help us process data that is collected on hydrophones and learn more about underwater activity. So this project that I've been working on recently is all about identifying dolphins based on their whistle. So each dolphin, bottlenose dolphins in this case, makes a unique whistle, which is called their signature whistle. And we can learn a lot about what dolphins are doing underwater and what their behavior is and sort of their movement patterns by recording sound and trying to understand it. So this was a project that I worked on with a team of machine learning engineers plus a few dolphin experts, dolphin communication experts. One at Hui, Dr. Leila Saig, and then Dr. Franz Jensen, who's at Syracuse. And then also, if you attended Louisa's talk at 1:30, she talked a lot about this project as well. So Louisa Van Bieland and then also Piper Walters were the other machine learning engineers on this project with me, who did a lot of really, really cool work for this. So kind of the idea that we were playing with in this project was to work with Leila and Franz to take this really large data set of individual dolphin recordings that they had and be able to automatically identify which dolphin was making which whistles. And this data set that they had was really unique. They were able to individually record different dolphins in this population in Sarasota Bay, Florida, which is not something that many people can do for a population of dolphins that they might be studying. And so the idea was to take these individual recordings and then be able to sort of extrapolate that into a larger sort of, to enable a larger system of monitoring the dolphins. So this map that you see here is of the different places in Sarasota Bay where there are hydrophones already stationed there, or there will be in the future. So you can kind of imagine if we're able to identify different individual whistles that we're hearing on these different hydrophone recordings all around the bay, then we can tell like, oh, okay, this dolphin was right here at this point, and then we heard them again over here, and we can learn about their movement patterns, especially as a result of different things that might happen, like a red tide. If that occurs, does their, how does their behavior change? And dolphins are top predators, so they're an indicator species for the rest of the ecosystem. So if they're sort of doing wacky stuff that we don't expect, maybe that indicates something else about the rest of the ecosystem and what it might be experiencing. So to give you an idea of what the challenge was that we were kind of contending with here, I'm going to play you a dolphin whistle, and then I'm going to play you 4 options for which dolphin produced that whistle, and you can take a guess at which dolphin you think you just heard. So this is the mystery dolphin first. Okay, hopefully you could hear that. I'll play it again. Okay, so now I'll play you the 4 options for the different whistles. That's dolphin number 1, dolphin number 2, dolphin number 3, okay, and then dolphin number 4. Okay, so if you have a guess for who it was, which of these 4 options, you can put it in the chat if you feel so inclined, or just think in your head which dolphin you thought it was. And to me, these all sound very similar. Like, it's very hard to tell the difference, and humans aren't as good at listening and differentiating between like really high pitched sounds like a dolphin whistle. So what we actually do to make it a little bit easier is oh cool, the guesses are coming in. Oh, I think, yeah, things are a little delayed. So now I'm seeing all your guesses. Perfect. Yes. So, so what we do to make it a little bit easier for us to be able to look at these and evaluate these different whistles, and also to be able to feed this type of bioacoustic data into a machine learning model, is we create spectrograms. We do signal processing to make a picture of the sound. So a spectrogram is what you're seeing on the right over here. So this is basically a visual representation of the whistle, the mystery whistle that you heard previously. And so a spectrogram is a plot of the sound. So on the x-axis is time, and on the y-axis is the frequency or the pitch of the sound. And so now if we look at the different options for the mystery whistle, to me at least, it's a lot easier to tell the difference between them when they look like this. But again, they are still just white squiggles, you know, so it's still not a really straightforward task. And it does take expert supervision to be able to label these whistles as the different individuals. But now, hopefully the task is a little bit easier for you, and you can see if you agree with your previous guess or if you would like to change it to a different one. And I'll reveal the answer in 3, 2, 1. Dolphin number 2. Okay, and I definitely saw some dolphin number 2 guesses before, so you all have good hearing. The dolphin whistle recordings always remind me of that ringtone that I feel like when I was in middle school, people would play it all the time because it was so high pitched that teachers couldn't hear it, because as you get older, your higher frequency hearing abilities get worse and worse. So that's what these whistles remind me of. Okay, so now I wanted to show you a little bit of like what we actually built for the scientists to be able to use, because that's a really important part of this project, was to be able to enable users who don't have a lot of coding experience, usually don't have a lot of like AI and machine learning data science experience, to be able to utilize the results of these models really easily. So we built them a UI that you can actually look at if you have a Google account. I think it asks you to sign in, but anyone can look at it. So the URL is up there. And what we it's not, I guess, super fun to use if you don't have dolphin whistles to play with, but you can basically upload any length recording that you might have. And the first sort of step is that we have a whistle detector in there that will go through, and it will pull out any points in the recording where it thinks a whistle occurred. The scientists can go through and either agree or disagree with all the results of the detector, and then it will take all the whistles that were confirmed and put them through our dolphin classifier, our identifier model, and it will spit out this type of visualization. So for each whistle, it will give its top three predictions for which dolphin produced that whistle, and give you a little picture to be able to visually match things. And in this case, F159, that's actually the correct dolphin. This whistle that it displays as the example one is kind of hard to see, but if you look closely, it is a sort of jagged thing with a big upsweep at the end, just like this input whistle. And then I just have one more example of another one. Another thing that was cool that we discovered, dolphins, their signature whistle can have different numbers of repetitions in there. And so, for instance, like this example one, you can see there's like 2 repeats of this basic shape of its whistle. And in the like sample one that the UI shows to be able to have people match to it, it only has 1 repeat of this basic structure of the whistle. And so that was something we were exploring, was like, will the model be able to still say like those are the same whistle even if there's different numbers of repeats? And we discovered that yes, it would be able to. So that was an exciting result to find. So that tool was really cool to be able to work so closely with the dolphin communication experts on developing. And now I just wanted to sort of show you some more examples and resources that you can look at, and organizations that you might be interested in if you're wanting to also work in this data science for wildlife space. So a couple organizations building tech for wildlife. WildMe is one of my favorites. They do a lot of really cool stuff, specifically with individual animal identification. So they take species that have unique patterns that you are able to differentiate individuals, and they build machine learning platforms to help researchers do that individual identification process more automatically. Earth Ranger is a really neat tool that is basically enabling different wildlife parks to be able to have a more succinct and sort of visual view of their whole park on a map that they can access, and they can, you know, plot different things that occurred if there were like incidents, or they can track animals if there are animals in their park that have trackers on them. They can see that in the map as well, and it just enables a lot of really more sort of streamlined management of wildlife parks using a map-based application. Global Airborne Observatory. This is tied to Arizona State University. It's kind of like Greg Asner is the PI. He does a lot of really cool stuff, but their sort of overall mission is to use aerial mapping of different landscapes and like corals, and they do all kinds of stuff to use sort of sensors on an aerial platform to be able to learn more about different ecosystems. So they're using a lot of different technologies in that mission. A few different volunteer opportunities as well if you want to volunteer your time in the wildlife data science space. Orca Sound is a really amazing platform. They have hydrophones listening to orcas throughout the Puget Sound, and they are collecting a lot of recordings and building tools to be able to label them more automatically, and also have a lot of volunteers listening to the hydrophones as well. So there's some like open source stuff you can contribute to, or you can just listen to the whales. Zooniverse is an online sort of crowdsourcing data labeling platform. So people can upload their data and get crowds of people to help them annotate it.
Sorry to interrupt. If you want to have time for Q&A, you'll want to wrap up in the next minute or so.
Okay. Yes. Let me just run through. I just have more resources. Yeah. Thank you. So the Conservation Tech Directory is a list, fully like community sourced list of resources and university labs and organizations and tools related to conservation tech. And I created this with a colleague, Carly Battist. We were both like frustrated that there were so many people working on sort of similar things within conservation tech, and they didn't necessarily know about each other. So we wanted to create like a one-stop shop to learn about all these different resources. So if you're interested in getting way more resources than what I'm sharing here, I would say definitely check out the Conservation Tech Directory. FathomNet is another free open source resource that they're trying to collect like as many different underwater images as they can of all different species and get them labeled and create this giant data set that can be used for training computer vision models for underwater animal recognition. Seek is like one of my favorite applications of machine learning for wildlife and for just like nature in general. It's an app that I use all the time to be able to identify different plants and animals and mushrooms and things I'm seeing out when I'm hiking and stuff. And it's all machine learning powered. So I love that app. And if you're looking for like jobs specifically in this space, or like environmental space / climate tech, data science space, all of these different resources are really helpful. A lot of them are job boards, and then this AI for Conservation Slack channel or group is a community that I rely on a lot for like learning about what's going on in the space and finding relevant papers and connecting with people. So for that one specifically, if you're interested in joining, you can email me and I'll send you a link to be able to join. And then here's my contact information. So if you're wanting to connect, please feel free to reach out. And thank you for coming. and now I'll get to Q&A.
Thanks so much, Gracie. If you want to answer one question, we'll have to end soon, but people can always follow up with you afterwards.
Yeah. So one is, how many individuals are identifiable by call/voice in Sarasota? Hundreds, thousands. So in our data set, we had about, I think 70 some individuals. I'm already forgetting somehow. Louisa, if you have a better answer, you can type it in the chat. But there were about 75, 77 or something like that. But ideally, that was how many we had that were like labeled and had enough labeled data to be able to identify them. But ideally, we'll find a way to keep adding more to the model in the future so that, more of the population can be automatically ID'd using our models.
Thank you so much, Gracie.
Yeah, thank you, everyone. This was really fun. Have a good rest of the conference.
You too.